Good day. I'd like to present context linking tokens, a solution for linking context to derived datasets immutably. We present here the context linking tokens concepts, which we will describe at length through the remaining slides. Context linking tokens are a proposed adaptation of the non-fungible token concept to address the challenges of managing data architectures at scale. This concept may have wider-ranging implications for providing distributed trust in derived datasets, as well as potentially tracking the integrity of public information such as government communications and commercial news articles. Further, if we accept that all personal data could be treated as a derived dataset and enable it to be minted automatically, then CLTs could be used to protect ownership of personal datasets requiring a formal license to use. We present here a minting process which ascribes ownership to individual derived datasets and facilitates the licensed use of single or multiple copies thereof. Public and private registers of derived datasets and their founding sources are captured either publicly or privately and provide a reference for CLT ledgers. On the right-hand side, we have the ledger relationship to each of the derived datasets. Individual CLT ledgers track for a given derived dataset all of its founding sources, as well as every derivation step, along with any additional and relevant contextual data. Ownership of derived datasets and accountability for accuracy and fitness for purpose is thereby tracked immutably. The terms dative and deriginal are defined later in the presentation. Creating usable, sustainable data architectures at any scale is difficult. It is difficult and expensive because the same original data can be abstracted so easily into many and many varied forms. The utility of data, as we know, is a function of its form, but data form is in turn determined by its context. However, it is not possible to connect data to its context currently, and therefore data utility is a function of unconnected context. The problem we face when designing a common data architecture is how to most effectively quality assure other people's data. Where the data is my own and I understand its source and the steps I have taken to derive it, I have no problem. However, at scale, and doing this on behalf of many others as a service, the problem is compounded by the number of actors in the derivation flow. If we categorize the data into original and derived data, some benefits do flow in the communication of this concept. Original data is the raw data in its exact form in which it was created. It is the first genesis of the data. Original data can be machine-generated or human-created. For example, a to-do list on a napkin is an example of original data. It can be stored digitally, but this need not necessarily be the case. Derived data, on the other hand, is any data that is not original. It is derived from original data, from other derived data, or from a combination of the two. As we know, derived data is inherently untrustworthy, and other people's derived data more so. This is because before we can know that derived data is a faithful and useful derivation from its origin or origins, we must understand its context and validate all of the derivations that have applied across its lineage. Today we do this by centralizing derivation activities and recording the context as we go, using single-purpose systems such as spreadsheets or notepad files, monolithic ERP systems, even enterprise data warehouses, and possibly data catalogs. But this approach is slow, inflexible, and expensive, especially so at scale. We thought we had solved the data problem by building data lakes and filling them with raw data, but that just avoided the QA problem rather than solving it. Remember, other people's data is inherently untrustworthy, and now data lakes are a particular problem in data architectures. Much more data with even less context. But we are ever more data-centric. The rewards are just simply too great to ignore. Machine intelligence is magical in the Arthur C. Clarke sense of that word, but it is entirely dependent on derived data, and even personally derived data may carry unacknowledged bias. One approach, the data mess approach, tries to solve the problem by holding the other people responsible for proving the trustworthiness of their data. Data products are deemed to be the responsibility of the teams who create the derivations. But how far do you go? It's turtles all the way down or up. How to solve the problem of validating data at scale and attaching context. First, some new terminology. A dative refers to any derived dataset or any individual element of a derived dataset, and is to be distinguished from a deriginal, which refers to any original dataset or an individual element of an original dataset. Into blockchain and NFTs. Blockchain technology shifts the protection of trust from teams of people and centralized institutions to technology. It allows us to create distributed, decentralized ledgers of encrypted records that are effectively immutable given today's technology. NFTs, or non-fungible tokens, are an application of blockchains to immutably track ownership in unique digital assets. And as you will have seen, there has been a recent rise in the popularity of NFTs. The most public example is the recent sale at auction for $69 million of an artwork of 5,000 days of artwork by people. But what if we use blockchain technology to create a ledger of all derivations that we use to derive a unique dative from its founding sources? In other words, can we apply the emerging NFT concepts of tracking ownership in unique digital assets to tracking all of the steps applied to derive a given dataset, including potentially all intervening contexts? In doing so, we may create the potential to recognize the contribution of all actors along the value chain of the derivation. Such a solution could be the basis of a marketplace of expertise, with each contributor reserving rights in their individual component of insight, tracked as a distinct step in the derivation lineage. We could also establish distributed trust in news articles, with the full immutable lineage of every article being publicly visible, and all actors accountable for their component contributions. In closing, we remind you of context linking tokens. The process entails minting ownership to individual derived datasets, and it facilitates the licensed use of single or multiple copies thereof. Context linking tokens are stored in registers of deriginals and datives. These may be public or private, and they form the basis of the ledgers for each of the derived datasets. One derived dataset may build upon another, or it may build upon original datasets. Individual CLT ledgers track for a given derived dataset all of its founding sources, as well as every derivation step along with any additional and relevant contextual data. Ownership of derived datasets and accountability for accuracy and fitness for purpose can therefore be tracked immutably. Thank you.